As I often do, I have a question here for you to start off our thinking about our topics for today. So, if you keep a stack of papers on a desk where one is piled on top of another, and you're only able to add or remove from the top of that stack, say you don't want things to fall over, so you don't try to mess with things in the middle, I want you to think about what will be true of the papers you pick up each time. So I'll draw out a little. If I have a paper, I set one down, I pile another paper on top of it, I pile another paper on top of it, and then I remove one of those. What will be true about the one that I removed? And even if I now pile more papers on, and more papers on, and I remove again, what will be true about the one that I removed there in terms of the order, in terms of the features of those different papers? So you can think about this like if students are submitting their tests on a desk at the end of a class period and they pile up as students submit. Another way to ask this is what will be true of the test that I grade first if I can only remove from the top of that stack. So it would be a great choice to pause the video, even if you think you have an answer, and start to formulate a question or an answer a little more fully to this question of if you keep a stack of papers on a desk and are only able to add or remove from the top, what will be true of those papers that you pick up each time? So pause now for a moment. Think about it. And then let's think about what we can actually guarantee about those. So when I piled 3 papers and then I removed one, the one that I removed was the third one that had been added. When I piled more and I removed one, the one that I removed was the last one that had been added. So the thing that we could guarantee about those is that the one removed will always be the last one that was added. When my students are submitting those tests, the test that I grade first, if I pick from the top of the stack, will be the last one that was submitted. So this gives us a behavior about a stack of things. If we can start to think about the structure of when things are stacked on top of each other, then the behavior of that structure is last in, first out, also sometimes abbreviated as LIFO. Last in, first out. Whatever was last put into the stack will be the first thing I get out when I ask for something. Now, it's important to remember, though, that for a stack, this is not universally true. We saw my example here where I removed one and then I added some more. And so this last in, first out ordering will only be true of things that were added and that are still in that stack. So if I piled things up like numbers, and I piled up the numbers 1, 2, 3, 4, 2, 3, 4, and I then remove them. By the way, in a stack, the adding is often referred to as push, and removing is often referred to as pop. So if I push 1, push 2, push 3, push 4 on top of the stack, and then I pop and pop and pop and pop, I will get back 4, 3, 2, 1 in that order. 4 will be the first thing out because it was the last thing in. 3 would be next. 2 would be 1. So another little feature that we could get about this is if I push all the things on the stack, all of my students submit their tests and I don't grade any while they're submitting, and then I grade them starting at the top and popping off tests to grade, then I will grade them in reverse order of when they were submitted. However, this reversing order can be broken by pulling things out, by popping things off in the middle of the pushing of things. If I graded some while students were still working, I would not get a pure reversed order. So if everything is pushed all at once and then everything is popped off, I get things in a perfectly reversed order. If I mix pushing and popping, things will not be perfectly reversed. But I do get this behavior we talked about in the beginning. The last thing that was put in will be the first thing that comes out. And so we often focus on that guarantee and not necessarily whether the whole thing will be reverse order or not, unless you know you're pushing everything and popping everything. So as you may have guessed, the data structure that you're going to be looking at will be a stack where we sort of treat things as being piled on top of each other, and we're able to remove the most recent thing that was added, the last thing in. So the main operations for a stack are going to be push and pop. Sometimes people will add an additional operation because pop removes something from the stack. We may sometimes want to be able to peek and see what is at the top of the stack without removing it. Sometimes we may also do additional operations to know more information about the stack, and you're going to get a chance to play with some of those as you do sections A and B of the stacking queue activity.